straight line. Okay, a straight line graph. Okay, so for example, we can draw things like that. Okay, whereby for straight line graphs, okay, the equation, the format of the equation is always in your y equals to mx plus c, whereby m will tell you the gradient, okay, and then c will tell you the y-intercept. Right? Today what we're going to learn is to learn how does a quadratic curve actually look like. A quadratic equation is of this format, whereby a, b, and c are just numbers, okay, depending on the question, right? And a, b, and c contributes to different features of the curve itself, but we're not going to explore that. Okay, so in any quadratic curve, it usually comes in two different types of shape. Either it is like a U shape like that, or it can be a Z-face shape like that. Okay, so to show you the different shapes, I have generated over here, okay, a quadratic curve. So in this particular one that I have plotted out over here is of this equation, y equals 2.7x squared plus 0.2x plus 0.1. Okay, so I have over here different values of a, b, and c. Okay, so I'm going to just change the value of a, b, and c and to show you what happens to the curve. Okay, so for my value of a over here, right, I have it such that, okay, from a small number now, okay, currently it is y equals to 0.4x squared plus 0.2x plus 0.1. If I were to increase it, okay, we find that your curve actually gets narrower and narrower. It goes inwards, okay, when I increase the value of a. When I change my value of b, so currently if I were to increase it, I find that your curve actually shifts. Okay, there's no particular way in terms of shifting it. We're not going to explore it today. Okay, then for c itself, notice that your curve just goes up and down. Okay, so that is what we observe about it. But in all the changes that I have made, okay, notice that the shape itself remains this U shape. Okay, and that is because my a value, which is the first one over here, okay, it is actually a positive number between 0 to 5, not including 0. My value of a over here cannot be 0. Why? Because once this is 0, that means that it is a 0 times x squared. Essentially, there's nothing over here. And that results in y equals to bx plus c. And that will be no different from a straight line equation. So that's why for a quadratic function, okay, in order to have the x squared, okay, your a cannot be equals to 0. So now, what if I were to change my a to become negative? So let me just change this in between negative 5 and 5. Okay, so if I were to reduce my value of a to become negative, so notice that my a value over here is now negative 2.4. The shape of my curve actually changes, okay, into the other shape, going downwards. Okay, whereas initially when it was actually positive, from what we see over here now, it is a equals to 1.7. My shape is actually going upwards. Okay, so what I'm showing you over here is that to determine what is the shape of the curve, it is dependent on the value of a. In order to be of this shape, your value of a must be more than 0, it must be positive. In order to be this other shape, your value of a must be negative. Okay, how do we remember that? I will typically say that remember the graph sheet lah. Okay? Questions? Alright, so let me bring us to the worksheet now. Okay, let me show you. Okay, so in your worksheet, your notes, you will find that okay, I summarize it for you already. So you can pass one copy down to me now. Thank you. spaces. Okay. So in this particular case, our minimum point being here, I can have a line of symmetry, okay, being drawn through the minimum point such that I will have two exact halves, one on the left and then the other one on the right. Okay. Likewise, for this particular shape, I can also have my line of symmetry join through the maximum point, okay, and then I will get two exact halves. So important feature about quadratic curves is that it is symmetrical, and that will be how, that will be how it will guide us, right? In terms of our drawing, you must ensure that it is symmetrical. They must look like it is symmetrical. You cannot have one maybe going upwards like that, the other one goes slanted another way. Okay, then it's not symmetrical anymore. Okay, so the symmetry aspect is very important. Okay, so this is the line of symmetry. And our line of symmetry is actually a vertical line. Okay, any questions so far? Right? Last point that I want to cover in this set of notes is that the graph may have 0 x-intercept, 1 x-intercept, or 2 x-intercept. We will explore that, okay, further when we hit set 3. Okay, but I want to demonstrate to you how does no x-intercept look like, 0 x-intercept. So if I have a U-shaped graph, a happy face graph like that, 0 x-intercept will look something like that. It means that there is no touching between the curve and the x-axis. Okay, so this could be how 0 intercepts look like. 0 x-intercept. Okay, question is coming. Okay, so that's 0 x-intercept. Another case would be when there is 1 x-intercept. Okay, 1 x-intercept following the same shape, you can have something that is like that, touching the x-axis at only one point. Okay, so this is where we have 1 x-intercept. Okay, and then lastly, to have 2 x-intercept, that is what we have already over here. Okay, we can have the reverse when it comes to a less than 0, when we have our set base curve, just that it's the other way around. Okay, so more on that when we go to set 3. Okay, any questions? Alright, but the key thing is that there will only always be one y-intercept. Your curve can only pass through your y-intercept one time only. Okay, and it must be of this shape, U-shape, happy face or else sad face. Cannot go other way around. Okay, if you have your curve this side more, okay, it is not quadratic anymore. Okay, you cannot have your curve looking like that. Alright, it is no longer following our quadratic equation over here. Okay, questions? Alright, no questions. Let's do example 1 first. I know that we are very excited to draw, but let's just get past some of these questions first. Okay, we must learn how to interpret a diagram, how to read a diagram first before we can draw any graphs. Okay, so in example 1 it says the diagram shows the graph of y equals to 2x minus 2 times x plus 3. So this is a quadratic function that has an equation for which this is the equation. It says that the graph cuts the y-axis at point A. So when we use a capital letter, that is referring to a point, it has coordinates. Okay, then it passes through the x-axis, okay, at two values. When we use small letters, those are values that we're looking at. So in part A, question is asking for coordinates. So coordinates must come in bracket, two numbers inside it. Okay, so since we're looking for coordinates of A, and A is actually the y-intercept. Y-intercept is referring to here. Okay, when it passes through the y-axis, your x must be equal to 0. Because you look at understanding this coordinate over here. For this particular point, okay, what would the x coordinate be? We read the graph by going upwards to the x-axis.
In order to since y go down
equals to 0. So, to solve part A, when x equals to 0, yes, come in. Wait, come in. Is she doing better, Rose? Okay. Yes. Y is what? Y is x equals to 0. Okay. Maybe let's wait for the 6 first. Settle down. Yeah. F1. Equals to 0. Okay, because this point is here such that when we read upwards, your x-axis tells us that the reading is 0. That's how we read a coordinate. When we have this point here, how do I know what's the coordinates? I read downwards, right, to see what is the number, and then I read leftwards to see what's the number, right? So if this number here is A, this is the x-coordinate because it's on the x-axis one. And then after if I read here, it will be B, it will be the y coordinate because it's on the y-axis. That is how we read coordinates. Remember? Understand not? Okay. So if let's say I choose this point over here, okay, and then after that, how do I read it? I will read upwards to the x-axis. If this value is C, because it's on x-axis, it must be C over here. And then after that, I will read here, okay, if this value is D, it must be the y coordinate because it's on the y-axis. Clear? Okay, so that is how we read our coordinates. Just fill this up first. Okay, so at this particular point where A is, your x is equals to 0. That's why whenever we're looking for y-intercept, your x must be equals to 0. Okay, because y-intercepts are points that are going through your y-axis. Any point going through the y-axis, x must be equals to 0. Alright? You have this point here, x is 0. This point here, x is also 0. Any point on this vertical line, x will be equals to 0. So we let x equals to 0, then we can find out what is y. So 2 times 0 minus 2. Okay, and then after that 0 plus 3. So what I've done is I replaced all the x's with 0. Okay, I substituted it. So you can press into your calculator to calculate. Negative 2 times 3, that will give us negative 6. But this is not the answer. Question is asking for coordinates. So the coordinates of A will be 0, negative 6. Okay, I label the A. The coordinates is actually the one in brackets, 0, negative 6. You must have the brackets because that's how coordinates are being written. They are actually the x-intercepts of your curve. So for x-intercepts, okay, we don't know what is the x-coordinate because they are labeled as k and h, right? But we know what is the y-coordinate. The y-coordinate is when I have my point, I go towards the y-axis and I see what is the number. The number is 0. Okay? So for any point that is not on the x-axis, your y must be equal to 0. Right? So therefore, I will let y equals have learned how to solve. It is factorized. We have 2x minus 2 and x plus 3. So I can say that 2x minus 2 equals to 0 or x plus 3 equals to 0. Okay? So then we get 2x equals to 2 for the one on the left, and x equals to 2 divided by 2, which is 1. Okay? Then we solve x plus 3 equals to 0, so x equals to negative 3. Right? But we cannot just leave our answer like that. We're trying to answer the question, what is k and what is h? So in this particular case, what do you think is k and what do you think is h? Can k be equals to 1? K cannot be equals to 1 now. Why? Because k is found on the left of 0. And on our number line, left of 0 will have to be negative in value. So k must be negative 3. Okay? Then h must be equals to 1. So you must refer back to the graph to know, okay, what is the value of k and what is the value of h. It is not by guessing. Okay? Sorry, the people. Pass it, okay? When we look at chapter 1 this year, vertical lines, okay, they have a certain equation form, okay, that must be x equals to something. So the name, okay, the equation of the line of symmetry of any vertical lines must be called x equals to something, and this star over here is this value that passes through the x-axis. Okay? So the thing now is, what is this value that I'm trying to find? Okay? So this value over here is not 0, 0 is at this point of intersection here. Okay? This value, okay, because it is where the line of symmetry is, it cuts the curve into two equal parts. I already know what is the value of k, which is negative 3. And I know what is the value of h, which is 1. So this is going to be right in the center between negative 3 and 1. Because you cut into two exact halves, alright? It is right in the center. So it is like finding average of the two values right in the center. Okay? So the value of x will be negative 3 plus 1. Average, right? Is to add the numbers up. Then after that, because there are two numbers, we divide by 2. Okay? So the equation will now be x equals to negative 1. And that is the equation of the line of symmetry. So, if in your answer blank, in your test or exam or whatever, you must write down the entire thing x equals to negative 1. Okay? It is not just negative 1. It is not an equation. An equation must have equal sign with it, and it must be x equals to negative 1 in this case. Okay. Question? If we don't have questions, would I get you to turn to your textbook, page 119? Okay, I want you to attend practice down 7 on your own. Okay, this question. I want you to write your answers into your notebook. Okay, we are trying to find the coordinates of A, B, and C.
Okay? Then over here you do your cross method. 个可以关我